Hello, everyone, and welcome to our webinar on unmasking money mules. We're super happy you could join us today. Before I pass it off to our speakers, a couple of things. First, we will save time for a Q&A at the end of this presentation. You can drop your questions into the Q&A panel at any time during the webinar, and we'll do our best to answer them at the end. Second, you'll find some additional resources related to today's subject matter in the Handouts tab in the Berni interface. I invite everyone to take a look at those. And now it's my pleasure to pass you off to Thibaut and Andrea.
Hello, everyone. Very pleased to be hosting this webinar today on a topic that is super interesting and a great use case for graph technology. So we're very pleased to start this webinar and to provide you a full demo of our graph tool, investigation tool, Linkurious. So let's go right ahead. So I'm Thibaut Kellam, so I'm the head of customer success at Linkurious. And today I'll be with Andrea Berni, who is the senior solution engineer at Linkurious. So both of us, we are part of the customer success team, and we have now more than 5 years experience at Linkurious, bringing graph technology projects to production within top-tier financial institutions, with a specific focus also on financial crime use cases. So as a quick summary, Chris, introduction to Linkurious. So we're a company that was founded in 2013. We have one office in Paris, France, and another office in the East Coast of the United States. We have more than 50 employees, and we're pleased to be supporting more than 10,000 clients worldwide, analysts and investigators who are users of Linkurious Enterprise. The clients we work with, specifically in the area of anti-financial crime use case, we work, for example, with RIA money transfer and on anti-money laundering investigations, Zurich Insurance, in order to support them in their fight against insurance fraud. And we also partner with have key partnerships with graph database providers such as Neo4j, AWS, and also data science platforms such as Dataiku. So as far as the agenda, we'll start by giving a brief overview of the specific challenges of money mules and why we think that graph analytics is a great added value and really key to stop money mule networks at scale. So in order to show that, we'll give you also an introduction to Linkurious Decision Intelligence Platform. And of course, we are on that by a demo of an investigation in Linkurious Enterprise of money mules networks. So what are the challenges of money mules? So let's start with quick definition. So money mule is someone who transfers or move illegally acquired money on behalf of someone else. So money mules are used by criminals to quickly move illegal proceeds, so from one bank account to another, one foreign into another jurisdiction, for example, with the intention of quickly cutting the ties between the funds and the beneficiary to really make it harder to trace back the origin of the funds. Recently, the rise of money mules as a money laundering technique has been associated with the surge of online scam and social engineering and all the rise of online frauds, and also associated with the strengthening of anti-money laundering, anti-financial crime systems that financial institutions have put in place. And typically, in that situation, money mule schemes exploit the fact that trusted accounts face less scrutiny, whereas accounts with no prior issues, for example, that don't have a specific risk score associated to their profile, to their behavior. And large, unusual transactions trigger red flags, but small transfers often go unnoticed. So why it's important to fight money mule network? Well, it's I would say it's a twofold. There's two. The first is, of course, to fight or to stop criminal activities, and the fact that money mule, being a money laundering technique, It facilitates the fraud, any criminal activities that generated illegal proceeds. But more and more, what we see is that criminal organizations have worked on outsourcing the money muling to, I would say, innocent victims or oftentimes unaware people recruited online and they think that it's a victimless crime in the sense that they're just asked to move money from one bank account to another, but at the end they're being accomplice of criminal networks. So it's really about stopping criminal groups and their intention of inserting illegal proceed into the legal economy, and also protecting innocent victims. What is the impact of money mules on the financial system? So a recent study conducted in Ireland showed that about 1/3 of individuals between 18 and 24 years old declared that they'd be willing to use their bank accounts to help transfer illegal funds. And a recent coordinated operation led by the European Police, Europol, showed that or identified more than 10,000 money mules in a 3 months worldwide operation, and also reported approximately more than 100 million loss from victims of fraud that had transited through money mules, as per this latest coordinated action. So it's a worldwide issue. It's a rising issue, and it's also associated with the fast rising of all the online techniques, online scams, online fraud that is really been on the rise recently. So what are the specific challenges of detecting money mules? So the main issue is that by definition, money mules are isolated individuals, and they represent low value transactions, but on high volume and high velocity. So typically a bank that would face money mules would face small, isolated, separated transaction in a very reduced period of time that is very hard to tackle for AML systems, fraud systems that are geared with a risk-based approach. With individuals, also unsuspecting individuals who don't have the typical hallmarks of fraudsters or criminal associations, and they're being targeted specifically because they have this unsuspecting profile. And it's usually also cross-border and multi-jurisdictional operations that makes it also very hard to trace the funds at scale, at the level of the whole money mule scheme. And of course, that goes also with the exploitation of technology and anonymity tools to make it even harder to trace back and to identify the stakeholders of those kind of schemes. So what is the specific, and we're starting to get into why we think graph analytics is key to identify threats that would otherwise go unnoticed. Typically, what we would see is that money mules and the specific financial transaction operation associated with money mules would be considered as outliers within the anti-fraud AML systems of financial institutions, in the sense that they would represent isolated, low-value operation, represented here by the red dot, for example. And what those type of traditional risk anti-fraud AML systems, what they would miss is the potential connections between here what we call corridors of normal behavior. And this is where the value or the key hidden insights are hidden, is within those small hidden connections within the normal patterns of behavior, which is typically here what would happen with money mules. You would have a series of normal behavior, but if you're missing the global, I would say the full scope and the full context, you might be missing the connections that graph analytics would allow you to find, that would allow financial crime analysts to find those connections between those type of corridors of normal patterns, and hence identify potential hallmarks of money muling that would otherwise go unnoticed. This is specifically true due to the fact that really money wheel networks can be analyzed as graphs at the end, because what we would see at the level of a financial institutions holding, proposing bank accounts, managing bank accounts, is that you would have here represented kind of like in a rough schema of a graph. On the left, the funds that would be entering the institution via a series of deposits, small wire transfers done by apparently isolated individuals, with funds transited through hub accounts within the institutions. So to add kind of like a layer of complexity, and those hub accounts would be used as pivot accounts to then redistribute the funds and exit them outside of the institutions, either to external bank accounts or via online purchase, phone payments, for example, or withdrawn directly from ATMs. So since you can see that we could, money mules could very well be understood as a graph issue, a graph problem, and modelized as such, it becomes imperative to have a full understanding of the context to make the right decision, because building the connections here in the form of graph visualization, graph modelization, it becomes possible or enables law enforcement, financial institutions to really leverage their whole data, break the silos, and build the connections between, for example, individuals, personal identification information, PIIs, digital fingerprints like IP address, devices, financial transactions, bank accounts, basically building the connections wherever you have the data, even leveraging external data to find even the most smallest hidden connections that will allow to have the full context behind and build really networks and make the jump between isolated, I would say, outliers. We've seen isolated events such as a transaction, a fraudster, and a larger scope of investigation such as a complex criminal networks and a large volume of transactions and of operations. So on top of that, graph for money mules being modelized as graph, leveraging graph technology also makes it possible to leverage graph analytics to help make sense of complex connected data. So graph analytics basically works and runs through what is called graph algorithm. That are basically computational methods designed to analyze relationships and patterns within connected data, to enrich that data and reveal hidden insight leveraging network properties. So basically adding, for example, scores, labels to nodes and relationships to entities in your graph based on the specific properties of the graph. So their position in the graph, their influence within the network based on, for example, the number of other entities they're connected to, which and basically leverage different types of categories of algorithms such as pathfinding, like shortest path algorithm between two nodes. What is the shortest path that connects two nodes, for example? Centrality algorithm, such as who is the leader of this group of persons. Community, to identify clusters of entities within my data. So, for example, is this money laundering part of a larger network based on its position within the graph? And similarity, for example, is there a criminal network with a similar structure to this and my data, and basically kind of like sharing or using the same patterns or the same techniques of fraud, for example. So all that is possible, and we enable really to at Linkurious through Linkurious Decision Intelligence Platform. What we do is bringing graph technology, so graph analytics, graph-based alerts, and graph visualization at the level of business users, meaning financial crime team, fraud teams, anti-money laundering, compliance team, or however you call it in financial institutions, but also law enforcement, to really leverage the power of connected data to find, investigate, and report hidden insights and really make the best out of your data. So the idea is that you retransform the data from, I would say, a burden, you have a lot of data, to actually an asset by really leveraging the hidden connections, building on those connections, and reveal the hidden insights in your data. So how does it work? Basically, how Linkurious actually enables effective context-based intelligence. So the idea is to bring, for example, of course, internal data to modelize as a graph, but also to combine it with external data, such from company registries, third-party data providers. What we provide is a graph-powered decision intelligence platform, leveraging entity resolution, alerts and case management features, AI in graph analytics, and search and visual investigation. All that with the idea of enabling analysts to make confident decision using the full scope of, I would say, having a 360 view of their data and the specific targets of their investigation. So what our customer say about Linkurious, for example, in terms of ROI, is that thanks to this our decision intelligence platform, they're able to detect up to 20% more suspicious cases, reduced by 30% time spent on triaging alerts, so meaning also reducing the number of false positive, also reducing the time spent on collecting the data from different sources before actually doing the analytical work, and thus investigating 10 times faster specific threats and cases. So let's go ahead and set the stage for the demo, because this is actually what we want to do, is provide a real demo of Linkurious with a Money Mule investigation. But before that, I'm going to hand it to Andrea, who's going to explain how we built this demo in Linkurious.
So thank you, Thibaut. Now is indeed time to demonstrate how graph analytics can help detect Money Mule networks efficiently. In this demo, we will use a fictitious dataset representing bank transfers, where we'll have information about clients, personal information, and digital fingerprints. And as explained by Thibaut, all this information will be then transformed into a graph of interconnected entities. Our goal is, of course, to identify suspicious communities of accounts that might be involved in illicit activities. To achieve this, we will leverage advanced graph algorithms to analyze connection and detect patterns that traditional medias might miss. Then we will use this result to generate alerts in the Linkurious platform. With the alerts, we will be able to visualize the result, and lastly, analyze if they correspond to a Money Mule rings or not. To start, we will use one of the most famous graph algorithms that is called the Louvain algorithm. We will use that on our graph database, and we will use it to detect cluster of connected bank accounts. But what does it mean in simple terms? So imagine a social network where friends are naturally grouped into communities. Similarly, the Louvain algorithm helps us group bank accounts that interact frequently. And these clusters might indicate coordinated activities, such as for a Money Mule ring transferring funds between multiple accounts to obscure their origins. By running this algorithm, we can reveal hidden structure in the transaction network. And as you can see in this slide, we have a very simple example with a small graph in which different nodes has been grouped together by color. And here, of course, we're using the Louvain algorithm. In this case, is of course easy to detect that's for groups, even by simply looking at the graph, but it's completely another story when there are millions of nodes in a graph. And in that cases, graph algorithms are crucial. Next, we will apply another graph algorithm, more specifically the betweenness centralities, and we will use this algorithm to identify the most influential bank accounts within the previously detected communities. So in simple terms, death nodes are like busy intersection in a city where most of the traffic pass through, and it basically play a crucial role in connecting different routes. Similarly, in a transaction network, certain bank accounts, as explained by Thibaut, act as a sort of hubs or pivot nodes through which many transaction flows. And nodes with high centrality score may indicate key accounts used to move money across the network. Detecting these accounts help us understand the structure of illicit transactions. And once again, we have an example here in which there are three different communities with a node in the middle. This node in the middle has typically a very high centrality score. And this is because if you want to move from one community to another, you have to pass by this node. And by removing that node, many communities will get isolated. So that's why this node is considered crucial for the community, for the network, and it has a very high centrality score. Finally, we will use the insight from both algorithms, so we will combine them in order to generate an alert. We basically we will be able to consume the result in our detection model for identify communities that contain at least one account with a centrality. This type of account are usually considered at risk for the bank because, of course, are crucial in the topology of the graph. This means that if a cluster includes a central account with significant influence, the entire community is flagged for further investigation. This approach ensures that we do not just look at isolated anomalies, but rather consider the broader context of financial transactions. By leveraging both clusters and centrality measures, we improve our ability to detect and disrupt money mule operation efficiently. We can now move to the live demo, and so I pass the floor again to Thibaut.
Thank you, Andrea. Indeed, I'm going to switch to Linkurious Enterprise to provide you a demo of the platform. Okay, so Andrea set the stage for the demo. Basically, what you're seeing here is the result of the alert that Andrea explained, leveraging the two data preprocessing step, one to identify clusters of communities, and within those communities, retrieve basically nodes that at least one node that have high centrality score. The result, as you can see, is that we have a first case that has been generated. Where we can see we have a couple of information regarding the generation date. We have information regarding the volume of total of transactions that transited through this specific community and the number of clients that are involved within this community. So let's go ahead and investigate it and see whether or not it's a suspicious and can be considered as a money mule ring. So the first thing we see here is the actual result of that case, and we have a small, like a case management panel here, so I can already assign the case to myself and start my investigation. Okay. So let's go ahead. So what we see here is a couple of bank accounts and account holders associated with those bank accounts. What we see, we have different bank accounts shaped differently. We have bank accounts who are bigger than the other, and typically these would be the one with the highest centrality score and one with a lower centrality score here. If we select them all, we can actually have this full view here where we can understand the whole bank accounts that we have in our community and have all the centrality score showcased here. We also see a couple of financial transactions, actually 37 financial transactions that transited through these bank accounts. We can have an estimation or have a view on the amount. So we have a lower bound and a higher bound at the more than 2,000 euros worth of financial transactions. So at this time here, what I'm interested in is to understand a bit more the logic, I would say, on how this community works, how is it structured, and what is the flow of money between those bank accounts. The one, for example, here with the high centrality that could potentially be the hub account, and the other bank accounts. I want to follow the money, as we say, and run that type of investigation using graphs. The first thing I will do, since I have a lot of financial transaction, is I want to understand and really, as I said, do this follow the money investigation and understand the logic between the flow of money. So in order to do that, I'm going to select the bank accounts, and I'm going to run a first query called show money flow. We'll basically add an additional relationship linking or connecting bank accounts according to the net money flow between those two bank accounts. So what it will allow me to do is visualize between two bank accounts. Basically, if there's one bank account that has sent more money to the other bank account than it has received, it will create a relationship between this bank account to the other, to really identify and understand what is the logic of flow between the different bank accounts. So I'm going to run the query here. You can see we've added some financial relationship model here in orange, specific properties, and we have the amount of the net money flow between those bank accounts. What I want to do now is, since I have that, I want just to filter out the individual transactions, and I can already see, visualize a bit better the flow of money between this bank account with the highest centrality score and to the other ones. But to make it even more clear, since we're working on consolidated amounts, I can focus on the highest amount. So I'm going to filter out the low amounts and leave only the highest amount. And now it becomes clear the structure, I would say, in the flow of money. We can see that there's a flow going from this bank account with the high centrality score, going to this bank account, then to this one, and finally to this one. So what we can understand at this point is that we have an entry point to this community and an exit point here, I would say, so both extremities of this community, where we might have the funds that entered the community in this potential ring of money mules through this bank account and exited through this one. But what I want to do now is, since we have both extremities of the graph here, I want to return external bank accounts that might be connected to this one and to this one, to understand which bank accounts and how did the funds enter this community and to which bank account they exited. So in order to do that, I'm going to bring back individual transactions because we're going to need them here. Before doing so, since I'm going to add more bank accounts within my visualization, I want to just bring on a slight modification to the styling of those nodes so I don't lose sight of those important bank accounts. So I'm going to trigger focus mode, and I'm going to just add a specific styling to those nodes. Then I'm going to select the bank accounts again here. And I'm going to run a query returning external transactions. Okay, so now what we can see, so we have the two bank accounts. So the one here that we identified with the high centrality score being the entry point to this community, and we have the bank accounts here where the fund exited. So what I want to do is understand, as I can see, it's interesting because we can see a bunch of financial transactions to this bank account and other types of financial transactions going outside of this bank account. So I'm going to, what I want to do at this stage is leverage to understand if there's actually a timeline logic, I would say, to this financial transaction, to understand if there's, because what we would expect is that we would first have financial transactions going in that bank account, and then at the end, a financial transaction going outside. So have prior, and then later on, the financial transaction exited this bank account. So I'm going to leverage here the timeline. I'm going to use the date properties here. So I'm going to run the timeline directly from here. So now everything is filtered. So I'm going to need you to pay attention to those two bank accounts here. So first, at the level of the months, we can see that there were the the first transactions are the ones that actually transited towards this bank account here. Then we have a bunch more financial transactions entering the community. Then for this month here, we have a bunch more. So I'm going to go at the level actually of the day. I can see that I have a bit more, again, financial transactions coming in, still within the bank accounts inside the community. Again, as you can see, in the last 2 days, we can see that the financial transaction actually exited from this bank account to the external bank accounts that we have identified. So now it's become pretty clear that we have the bank account with the high centrality score, the most influential bank account that serves as a hub, so collected all those financial transactions here. The funds went through I would say the bridge account within this community, the one that we have identified here. And within the last days here, the last few days, they actually exited towards these external bank accounts. So now we understood basically the structure of this community based on the influential of the nodes according to the amount of financial transactions that transit to them, and we added also another layer of analysis based on the timeline, and understood also the chronological logic of this community. So now that we've done this transactional analysis, I want to take it a step further, and also understand if there are some interesting connections between the actual account holders. So in order to do that, I'm going to focus only on and go back to those bank accounts and the account holders. So I'm going to use here the lasso feature to select those bank accounts here. I'm going to go here, select them again. I'm going to perform an invert selection. Get them out of the way also. Refresh the layout. A couple of more here. Okay. And also just my bad. A couple of more here. Okay, and refresh the layout. I'm going to, so I have my bank accounts here. I'm just going to put back in the loop, in the graph, the account holders. Okay, and now what I want to do is understand if there are some, outside of just the transactional analysis, if there are some actual interesting connections between those account holders. So I'm going to select the person, run a query to find those types of connections, find connections here. And what we can see here is interesting is that we can see that some individuals actually here, for example, use the same device to so for example, these two individuals here, they use the same device. You can see here to actually access their banking application, for example, and perform those types of operation. So that's an interesting indication. We are able to find connections between and within the digital fingerprints used by this network, and we can see that it's a strong indication using the same device to access the banking application, perform the operation, is a strong indication of potential, well, a link between those individuals and, well, most likely money mules. But what we see again is on this device, I have additional connections here, which is interesting. I'm going to return that, and I can see that this individual Tommy Bricks that we identified as being the account holder of the exit account, well, the bank account that was used to exit the funds. He performed some phone payments here, so a couple of them, a couple of phone payments. And as you can see here on the phone payments, they're all, so if I, for example, select them all at once, you can see that they are all performed on the same day, just the day on which this bank account received the funds from the community. So I can see that clearly it was another way of exiting those accounts, the funds, by doing some phone payments, some purchasing. So that's interesting. So that's also a clear indication of another hallmark of money muling, where we had the funds entering this bank account, being transited through these transit account, exited through these bank accounts, sent to external funds, and also used to perform some purchases, some phone payments. What is interesting? So we have also a shared device. So the device, the shared IP address. Sorry. So IP addresses. We can see here that this IP address has been roughly located in South Africa, whereas all the payments have been done in stores in the UK. So we can see also that it's kind of an indication of possibly techniques that were used to anonymize their or obfuscate their digital fingerprints. So I'm reaching the end of my investigation. What I can do at this stage is that I can select all the individuals in my network, and I can, for example, I can flag them as confirmed fraudsters, confirm money mules, for example, run that, and you can see change the specific design of those nodes to indicate that we've identified them as money mules. What this stage also, what I can do, since I'm within my case management interface, is that I can confirm that case. Say confirm money mule ring. Save it. I can ping, for example, our colleague. Let's say Andrea is my manager. I want to ask him to perform a 4-eyes check on this specific case. He will receive a notification and an invitation to review this case. Again, if I'm also to conclude this investigation, let's say I'm the manager. So, for example, Andrea received this investigation. He wants to understand how this specific case stands within the global, I would say, performance of my team. What I can do is leverage the ability or the capabilities of Linkurious of connecting to third-party tools, such as BI tools like Microsoft Power BI, open a dashboard. So for that, just I'm going to change the sharing updates, sharing configuration of here. But what you can see now is a Microsoft Power BI dashboard that was built, fed with the data that is in my graph database, and that my team is using to analyze money mules, where I can monitor the performance and keep track of the KPIs of my team in terms of global amounts of block funds for last year, for this year, and understand, basically monitor the performance of my team. And at any time, I can go back to Linkurious here using deep links. So really having a smooth integration between Linkurious and BI tools. So that concludes my investigation. I'm going to stop sharing at this stage and go back to the slides to conclude this presentation, this demo, and get started with the Q&A. All right, I think we can go back to the slides. Okay, so that was the demo. Just as a key takeaways before switching to Q&A. is that we've seen that money mule ring represent a significant challenge for banks and law enforcement due to several factors associated with the high velocity, the small amounts, and the unsuspecting nature of more and more of the money mules, that it's become imperative to have really leverage the hidden insights within the data to go beyond just the outliers of money mules and really identify potential connections between money mules that will help financial crime teams to really identify them. So Linkurious Decision Intelligence Platform enable business teams to run graph algorithm at scale in real time to extract suspicious patterns within connected data that would otherwise go unnoticed with traditional tools. The combination of Linkurious detection features and risk investigation capabilities allows anti-financial crime to quickly identify, analyze, and report money mule threat in a proactively fashion and in real time. So that's it for our presentation and for our demo, and from now on, we'll gladly answer your questions.
Thank you both. Now we'll move into the Q&A. If you have any questions, there's still time to drop those into the Q&A panel, and we'll get started. So there's a first one here. What role does graph analytics play in distinguishing between legitimate transactions and structured schemes? Who would like to take that one?
I can start. So first of all, the idea is that, as we've seen, is that focusing only on behavior, I would say, in terms of identifying, for example, client behavioral analysis, behavioral patterns, which is fine to identify, I would say, isolated deviation to the norm, to normal behavior. Which is the challenge is when we've seen two types, is to identify what could be possible connections between different individuals who showcase, I would say, normal behaviors, but identifying and leveraging a full scope of possible connections through digital fingerprints, through financial transactions, through geolocalization, all that, it's possible to do it very quickly and at scale in graphs. So in that sense, it makes it really possible to, I would say, leverage a full scope of possible angles for your analysis to really catch the hidden threats, rather than just focusing on basically a transaction going above a certain threshold, or in terms of also so amount, but also amount versus time, for example. So graph really provides you the ability to have a very large variety and multiply the different tools that you can leverage to really identify fraud. I would say also that the difference is that it allows you to really make the jump between reporting, identifying and reporting isolated fraud, to really reporting full networks. And possibly what our clients say is that the main benefits of graph is the ability to make and identify connections between known fraudsters, for example, because they have like the key hallmarks of fraud, and undetected fraudsters because, for example, the upstream models have not been adapted yet to evolving threat, for example, but the connections are really already there in your data. It's just that your upscale systems, upstream systems, have not been, I would say, vaccinated yet to those evolving threats. So really building the full scope of transactions of connections allows you to really identify proactively and much more quickly and at scale all the potential connections between known fraudsters, where your transaction monitoring systems, your risk detection systems are strong, and also the new types of connections between with undetected individuals, for example.
All right, thank you so much. So we have another question here from Mauricio. What's the infrastructure need to implement it in for new customers? Sorry, I think let me clarify. I think the question is, what kind of infrastructure do you need to implement Linkurious to do this kind of work?
Yeah, I can take this one. So basically, everything you need is, of course, the Linkurious platform and a graph database. So we support a series of graph databases. So actually, we support Neo4j, memgraph, Neptune, and Cosmos DB. So once you have a graph database, you can simply plug a Linkurious Enterprise on top of that, and you will be able to navigate and investigate your data.
All right, thanks, Andrea. So we have another question from Artie. Does the detection extend to transfers made internationally, say offshore, or only within a certain part of the world?
So for this one, I'll make sure I understand correctly, but I can start with the first answer. Basically, the detection around transfers, you would be, or a client would be able to do it based on the data that he has. So it's the banking data that comes from his financial institutions. So he would be able to detect those transactions if they are actually present in their existing data systems. In terms of, so I'm not sure about the full scope of the question, but basically Linkurious would, and you could be able to detect any and build the connections and leverage the graph algorithm here on any types of transactions that are stored upstream in your existing data systems.
All right, thank you. So we have a question from Ada. How can we see the difference between IP addresses related to home broadband and hotspots?
Yes, so that's a good question. It's actually can also what the challenge that some of our clients face. So interesting. Also, we have we didn't show it here, but you could, for example, build a specific custom action, or basically a link to Google Maps, for example. So we have clients who indeed they have IP addresses, and what they can do is, since you have some geo coordinates, you can open a Google Street View, and clients would be able to distinguish if it's a home, let's say, or a broadband IP address, to differentiate between, I would say, a private IP address and one that could potentially be used by a large number of users. So in order to differentiate, to really distinguish between suspicious patterns in terms of sharing IP address and, I would say, standard normal behavior using broadband services.
All right, thank you so much, Thibaut. I see another person in the Q&A asking for the handouts via their email. I've noted it down, so yes, I'll make sure you get those. We have another question here from Anthony. How easy is it to integrate third-party data into the graph?
I can start, Andrea, and if you can complement if you want.
Yep.
So basically, clients who integrate external data within their internal data, they usually do it two ways. The first one is through kind of like a traditional ETL process, using external APIs to well-known third-party data providers like Factiva, Thomson Reuters, Dun & Bradstreet. And putting all that through the ETL process, the same that is used to feed data into the graph database. But what we also provide within Linkurious is the ability to fetch data directly in the Linkurious user interface. So one of the examples that we have through what we call the third-party data plugin, let's say you have companies, and those companies, they're not your direct client, for example. So you're lacking information on those companies. We offer the possibility to reach a company register, for example, and get access to the data, public data on those open registers in terms of beneficial owners, extract the data and put it back into the graph directly from the user interface. So To put it simply, external data could be done two ways: upstream through the traditional, I would say, the normal ETL process, and downstream directly in Linkurious Enterprise through the third-party data plugin that we provide.
Yeah, and what I can add here is that if you don't want to persist this information in the graph database, we also have another feature that is called custom action that let you basically visualize an external page, an external repository of information by keeping the context of the investigation. So let's say that you want to get more information about a specific bank account, maybe by consulting an internal page within your bank. You can launch a custom action. You can open the external page that will be focused on that specific bank account.
Thank you both. We have another question here from Elisa. What is the scalability of graph databases when analyzing big transaction networks? Can it be done in real time?
Do you want to get a try on this one, Leah?
Yeah, I can take that one. So we have customers that are currently working with millions and millions of transactions. The advantage of using a graph database is that navigating even multiple steps in the transaction network is highly performant. So compared to relational databases, the cost is really reduced. And we also have customers that are basically live injecting data directly in the graph database. So as soon as new transaction has been performed, this transaction is automatically injected also in a graph database, and this means that you can investigate this new transaction in real time in Linkurious Enterprise.
Thanks a lot, Andrea. So we have another question from Mauricio. How do you choose the targets of investigations?
I can take this one. So I can comment from the graph scientist point of view. So in our demo, we are targeting communities. So group of bank accounts that are basically sharing a lot of money between themselves. So that are basically highly connected. But we are only targeting bank communities in which there is at least one high risk node. And for us, for our demo, a high risk node is a node with high betweenness centralities. But this is just an example for our demo. So what our customers are doing is basically to define what they believe is risky, what they want to investigate. They can translate this behavior into a query, so into a graph problem, and then with our alerting system that is very flexible, you can basically generate one or multiple models for detecting that pattern in the graph.
Great, thank you. So we have a couple of more questions. Here's one from Adam. How does your solution integrate with existing systems like AML transaction monitoring or case management?
I think I take this one too. So in Linkurious Enterprise, we have a set of different tools for integrating with external application. So we have APIs. With an API, you can easily extract information from Linkurious Enterprise, or more in general, interact with the server. We also have webhooks. That is a way for pinging external system as soon as certain action has been performed in Linkurious Enterprise. So, for example, I say that you are closing a case in Linkurious Enterprise. Maybe you want to synchronize this decision in another external tool. That's possible with webhooks. We have deep links. That is basically a way for dynamically generating visualization based on external tools, and we generally we use webhooks for adding graph visualization into already existing tools. Like, for example, you have your list of AML cases. You want to visualize them in a Linkurious Enterprise within a graph. With a deep link, you can do that.
All right, thank you so much. So we have last one here from Laura. What's the best way to leverage graph analytics to improve the performance of our AI machine learning models for AML risk detection?
That would be the topic of a webinar in itself, but basically what we could say here is that you've seen graph analytics. Graph analytics can be also used to produce what is called graph embeddings. So basically leveraging, for example, the topology of nodes within a graph, but also creating labels in after from graph analytics. Those types of embeddings in labels can then be used to feed machine learning models and produce like feedback loops. So basically, this is the link that can be performed from graph analytics to machine learning detections or machine learning loops. We basically, we could talk about also graph rags, but that could be a topic of another going too far. Andrea, do you want to add something here?
No, nothing to add. Indeed, it's possible to make Linkurious Enterprise part of the machine learning methodologies. So you use, for example, cases. Since in Linkurious Enterprise, the last decision is made by humans, you can use their choice, their decisions as a feedback loop. So you can use that as a positive or negative feedback depending on the response of the investigator. Yeah, that's it.
All right, thank you both. And that's it. So thank you everyone for your questions and for your participation in this webinar. As I mentioned, we will be sending the recording around shortly if you'd like to rewatch or share it. And that's it. Thank you so much for being here, and we'll see you for the next webinar.
Thank you, everyone.
Thank you all.
Bye-bye.